So spectral characterization, I carried out the 1H NMR and FTIR spectroscopy, and from this data, if the metal binding site is confirmed using this spectroscopic characterization, and if the metal is there, then we go for the crystallization, and we use the three solvent that we saw in the previous slide. And after crystallization, relative analysis carried out from the DFT and Herpes surface analysis, and if the molecule, synthesized molecule, if show the good biological response from the DFT as well as the Herpes surface analysis and crystallographic analysis, then we go for the biological activity. And from the biological, we first carry out the DNA binding study, cytotoxicity, and antibiotic activity. From the DNA binding study, I use the ctDNA. Now, why I use the ctDNA? ctDNA is top famous DNA, and there is a two reason behind this. Why I select the ctDNA? First is it's easily available. First, and second one, that conformation of the ctDNA is very much similar with the human DNA. So, if the metal complexes are show the good response toward the ctDNA, it's mean that same response also we repeat from the human being. So that's why we use the ctDNA. Cytotoxicity carried out because of sometimes what happening, some of the metal complexes are show the good response against the DNA, but at the same time the toxicity is also increases. So this is not our goal. At the similar time we need to reduce the toxicity of the molecule. And after also we carry out the antibacterial activity. This is crystallographic analysis and instrumentation. Chapter 3. So in the chapter 3, the title of chapter 3 is copper complex of sulfur dimethyl in presence of the 3-methyl pyrimidine. Synthesis of the complexes. I use a 2:1 ratio of the sulfur dimethoxy and copper nitrate are dissolved in the BMS solvent, and the dimethoxy are dissolved in the methanolic solution and mixed using the reflux method, 35-degree temperature. I get the powder. The powder is in the pure crystalline form. And after getting the powder, I go for the 1H NMR FTIR spectroscopy, and then after go with the single crystal X-ray diffractometer using the 3-methyl pyridine solution. This is spectroscopic analysis. In the first one I did the 1H NMR spectroscopy. This is for the ligand and this for the metal complexes. So in this graph we see that the peak around the 10.92. That's so the NH bond is present in the case of the ligand, but the same peak is absent in the case of the complexes. So it means that the nitrogen here is absent in the case of the metal, right? Metal complexes. So this is the first confirmation. And second confirmation from FTIR spectroscopy, the stretching vibration around 3235 to 2997, it's absent in case of the Cu SDZ molecule. This is because of the SO2 and NH deprotonation. Okay. This is and also I carried out the theoretical FTIR spectroscopy and experimental FTIR spectroscopy. This is a few theoretical stretching vibration of a molecule. And if the metal is, from the that 1H NMR and FTIR spectroscopy, metal is there, so I will go for the single crystallized refractometer. Crystallized system is in the monoclinic system with the P2 1/n space group, and this is the 3D structure of my complex. Here, very interesting thing is that copper atom are sitting on the special portion 1/2, 0, and two solvent molecules are placed in the apical portion, and that methoxazole ring that called the pyrimidine ring are settled in the basal plane and is formed the bipyramidal geometry. So if why we need to study the geometry, why we need to study the bond length and bond length, because whenever you change the geometry, the effectivity of the drug is also changed, and that is confirmed from that X-ray crystallographic analysis. Now this is the dihedral angle and torsal angle. Why we need to do the dihedral angle? Because when you change the trihedral angle, the effectivity of the drug is also changed. Okay. So here the dihedral between the pyrimidine ring and amido ring is around 88.46 in the case of the metal complex and 77.6 in the case of the reported data of the ligand, and also compared with the reported data of the silver complex of sulfur diazine around the 77.8. So it means that after complexation, the dihedral angle is increases. And the same in the case of the torsal angle. The torsal angle between this moiety C1, S1, N2 and C7. Because why I select this one? Because that nitrogen is bind with the metal. So this conformation is changed whenever the metal is contact with the ligand. So this one is 172.71 in case of the metal complexes and 161.11 is in the case of free ligand. Now one of the important thing is inter-intermolecular interaction. So here in my complex, in previous that so that NH is bind with the glutamic acid and stearidine, right? So this NH is play a major role whenever we discuss about the antibacterial activity. So here that NH is also taking part in the intra-intermolecular interaction, and also in this compound, the CH2 interaction play a major role in the molecule stability as well as the molecule packing. This is the intramolecular interaction, and this one is the CH5 interaction. Here, the free solvent molecule also play a major role in the molecule stability via CH5 and pi-pi interaction. CH5 and pi-pi interaction, and here I list the CH5 and pi-pi interaction of my molecule. Now, after theoretical study, that called the Herpes surface analysis. From the Herpes surface analysis, we need to use the CI file, because without CI file we cannot carry out the Herpes surface analysis. Now, in the Herpes surface analysis, divided into 5 parts. One is the D-norm, second one is the DI, DE, SAP index, and coordinates. From first surface, we can see that the red dot is there. Now, what is the meaning of the red dot? That the distance less than the van der Waals interaction, and white dot means the distance is equal to the van der Waals interaction, and blue dot means the interaction are more than the van der Waals interaction. So if the red dot is more, it means that that surface is highly active toward the biomolecule as well as the near neighbor molecules. And in case of the DI, that show the donor areas, D show the acceptor area, SAP index show that the CH5 interaction, and in case of the coordinates show the pi-pi interaction, right? So here, that red dots here, that area are always responsible for the donor side, and that red dots are always responsible for the acceptor side. And in case of the SAP index, the triangle between the blue and red, that show the CH5 interaction. So that surface are very much active toward the CH5 interaction with the another molecule. Now, in case of the coordinates, that flat region is always responsible for the pi-pi stacking interaction, face-to-face interaction. So in my case, the nitrogen from the amido group as well as the oxygen from the SO2 moiety and nitrogen from the solvent molecule 3-methyl-pyridine have the more responsible for the intra- and intermolecular interaction, and that all the atom have the red dots. From the 2D fingerprint plot, we just discussed that 2D fingerprint plot was carried out for the percentage contribution, and from this figure we can say that in case of the copper sulfur dimethoxy, the hydrogen-hydrogen interaction is more compared to the ligand. And very interesting thing is that in case of the metal complexes, the CH5 interaction is 24.7, and in case of the diazine molecule is 13.7. So it means that our molecule have the more CH5 interaction compared to the free ligand, also as well as the same in the hydrogen. Now, lipophilicity. In case of the lipophilicity, lipophilicity of the copper complex of sulfur dimethoxy is 3.64, and in case of the free ligand is 2.79. So it means that our synthesized complex are more more soluble in polar solvent. As well as the porosity, the Voigt-Stich calculation, the copper complexes of sulfur dimethoxy have the more porous in nature compared to the diazine molecule. After the energy framework analysis, the interaction NHO, CHO, and CHO from the free ligand have that three that interaction are more responsible for the molecule stability. Gas-phase DFT study. So after this all the analysis, now I want to take out the reactivity as well as the effectivity and inhibition efficiency of the molecule. So that's why I take out the gas-phase DFT study. In the gas-phase DFT study, the correlation coefficient is around 0.98 and 0.93. Now, which means that the theoretical bond length and bond angle are very much similar to the experimental bond length and bond angle, right? So in case of the DFT study, we carry out in the gaseous phase because that temperature coefficient is not involved in that wave function. So whenever we discuss the DFT study, we cannot include the temperature coefficient, right? Now in case of the MD, molecular dynamics, we enter the temperature coefficient. So here there is no relation of the temperature in this, right? It's a 0 Kelvin temperature, right? Because it's totally theoretical. So now, if it's not goodness of code is not around the 1, it means that your bond length experiment data is not similar with the theoretical data. So if it is so, then we will not go for the DFT study. So here that is good, data is good, so we go for the DFT study. First I'll calculate the molecular electrostatic potential. Here we see that the blue area have the more negative in the nature compared to the red one. So it means that that area and that atom are very much responsible for the donor side and interaction with the biomolecule. Homolog energy. So here the first one is homolog energy of sulfur dimethoxy is 5.36 electron volt. In case of the metal is 3 electron volt. So it means that the band gap, if the band gap is less, it means that the molecule is soft in nature, and if the molecule is soft, it means that the reactivity and reactivity and stability of the molecule is more compared to sulfur diazine molecule. So here 5.3 in case of the diazine molecule and 3 is in case of the copper diazine molecule. So it means that copper are soft in nature and reactivity of the copper is far better than the diazine molecule. As well as also take to the hardness. The hardness of the my molecule, that is copper sulfur dimethoxyzine 1.5. In case of the diazine molecule is 2.68. So it means that the synthesized Patel complexes are soft in nature, and if the molecule is soft, then its reactivity is high. And also we carried out the maximum charge transfer delta and maximum, that for the inhibition efficiency. So here in case of the copper sulfur dimethoxyzine is 1.8, and in case of the diazine molecule is around 1.25. So it means that the inhibition efficiency of the copper sulfur diazine is more compared to diazine molecule. Numerical charge proportion carried out to calculate the what is called the charge values of that atom. Okay, so here the N2, N1, the nitrogen from the amide and nitrogen from the amide group have the more negative, as well as the oxygen from the SO2 moiety have the more negative in the nature. And from the NV analysis, the carbon from the free pyridine molecule and nitrogen from the pyridine molecule have the more responsible for the molecule stability. Using the NV analysis, we carried out because of finding the stability of the molecule. Okay. So from the theoretical data, we know that in the case of the copper complexes, that activity and what is called stability is high compared to the diazine molecules. So now we go for the DNA interaction study. And from the DNA study, using the UV visible spectroscopy, we calculate the Kb value. There is an equation for that. And Kb, if the Kb value is high, it means that the binding affinity of that drug is high compared to the another one. So here, in case of the diazine molecule is around 0.79, and in case of the copper sulfur diazine molecule is 1.3. So it means that the copper sulfur diazine molecule has a more binding affinity compared to the diazine molecule. As well as I also compared with the silver complex of sulfur diazine molecule is 1.86. So it means that now in case of the silver, the DNA binding interaction is more. So maybe the conclusion is that copper has the less binding affinity compared to the silver. But then also we carry out the DNA interaction study, theoretical DNA interaction study. I use one DNA as my target molecule, and if the more negative value is seen, the more binding strength. So here, in the case of the sulfur diazine molecule, dimethoxyzine molecule is minus 2 to 2.57, and in case of the copper is minus 249. So it means that the binding energy of the copper is more compared to the diazine molecule. So that copper is more binding in nature compared to the free ligand. And also compared with the that reported data of silver complex of sulfur dimethoxyzine is around minus 238, right? So it's lesser than the copper sulfur dimethoxyzine. Now viscosity measurement carried out to find which kind of the interaction happen between the DNA and our synthesis complexes. And here, if the graph is increasing in the nature, it means that the binding between the DNA to the synthesis complex is intercalation mode, and if it is straight, then is electrostatic interaction. Okay, so here the increasing nature show that the binding between the synthesis complexes and the DNA is pi stacking interaction. And that same thing that we previously presented, the hydrogen to the carbon interaction, that called the CH interaction, are more in case of the copper diazine compared to the diazine molecule, right? So that theoretical data also that similar with that experimental, it correlate with the experimental data. And also carried out the cytotoxicity. Cytotoxicity of the ligand is around 50.84, and in case of the copper diazine is around 6.2. So it means that this half compared to the ligand. So toxicity, whenever the copper is play its role, then toxicity is drastically reduced. Now I compare with the reported data that for the silver. Now in the case of the silver is 6.30, right? so see, in case of the diazine molecule is 15.84, in case of the copper diazine is 6.28, so the activity toxicity is half compared to the diazine molecule. Now, in case of the silver sulfur dimethylene, the toxicity is 6.30. So previously we discussed that in the case of the DNA intensity is more compared to the that copper complex of sulfur diamine. But at the same time, for the silver, the toxicity is also reduced. So if toxicity is also increased. So this is not our goal, right? Our goal is to reduce the toxicity as well as the effectivity of the drug. After also we get out the minimum inhibition concentration that called the MIC study, and from the MIC study, the minimum concentration required to inhibit the bacteria in case of the copper sulfur dimethylene is 9, 50, 65, 75, 80. This graph, and in case of the free ligand is, I think, 3 times higher than the copper complexes, right? So it means that whenever the copper are bind with the sulfur dimethylene, the minimum inhibition the minimum inhibition concentration are good compared to the diazine sulfur dimethylene molecule. And the same thing we repeat in the cell viability. Now chapter 4. Now I don't go in detail with the synthesis, right? The same synthesis we that discussed in the previous chapter. Here we also use the 2:1 ratio. NMR study. From the NMR study, the peak is present here that are absent in the case of the metal complexes, and that means that metal is now the metal is bind with the nitrogen from the amino group. From the FTIR spectroscopy, that some stretching vibration are present in the case of the sulfur pyridine molecule. That same are absent in the case of the nickel sulfur pyridine molecule. So there is another confirmation of the binding of the metal with the sulfur pyridine molecule. This is a few theoretical vibration. Now the crystal grow in the monoclinic crystal system with the P2 1 by N space group. This is my structure. Now here the same thing that discussed in the previous chapter, that copper here that copper is there, the nickel are sitting on the special position 1, 0.5, and 2 solvent molecules are placed in the apical position, and the nitrogen form, that pyridine molecule, are sitting in the basal plane and they form the bipyramidal geometry. Second interesting thing in this structure is the 5-member ring. This one, that solvent molecule is a tetrahydropyrrole that have the puckering at angle around 14.38. So the this structure have this puckering in the solvent molecule. This is a dihedral torsion angle. In case of the dihedral angle, in case of sulfur pyridine is around 84. Now in case of the metal is 79. So after complexation of the metal, the dihedral angle is reduces. This is the intermolecular interaction. Same thing here. The NS2 group also plays a major role in the intramolecular interaction, and that molecule form the R228 graphs molecule. Now what is it? 2 means the donor, acceptor, and the total molecule. Total molecule is 2 are donor and 2 are acceptor. Here also the solvent molecule tetrahydropyrrole are form the ring pattern throughout the CH pi interaction, and in case of the pi interaction, this one is the pi interaction. In case of the pi interaction, the amide ring and pseudo ring between the metal to the carbon, nitrogen. So that form that triangle type of the wave to increase the stability of the molecule. These are few intra and intermolecular interaction. In this case also, the CHO interaction are more compared to the NHO interaction, as well as one adding interaction is CHN interaction. So very interesting thing is that that NH2 group also play a major role as a donor, and at the same time it also play a major role as an acceptor. So NHO are in this structure, NHO play a major role toward the molecule stability. This is a few CH and pi interaction. Herpes sulfur. From herpes sulfur, previously we discussed that the red spot show the more interaction in nature compared to the blue region. Here, the nitrogen from the amide group and nitrogen from the pyridine group are the more donor in nature compared to the another carbon, and oxygen from the SO2 moiety have the more acceptor in nature. This is a 2D chemical plot. Here, in this case also the CH pi interaction are more in case of the nickel sulfur pyridine compared to the sulfur pyridine molecule. This is the lipophilicity. Lipophilicity of the, in the case of the metal nickel complex of sulfur pyridine is 2.99, and in case of the free ligand is 2.91. So it means that the metal complexes are more lipophilic in nature compared to the sulfapyridine molecule. From the porosity 15.2 in case of the nickel, and in case of the free ligand is 12.91. So in the case of the metal, this is more porous in nature compared to free ligand. This is energy framework analysis. From energy framework analysis, NHO and CHN interaction have the more energy compared to the another interaction. That interaction play a major role in the molecule stability. These are few interaction with that energy. Now from the MEED, the nitrogen from the SO2 moiety and nitrogen from the free solvent binding solvent molecule THP, and two oxygen from the SO2 moiety have the more negative nature compared to the another one. From the homology analysis, in case of the nickel there is 3.27, and in case of the sulfapyridine molecule is 4.42. So that the metal have the more soft in nature, and hardness of the metal is also less compared to the sulfapyridine molecule. And inhibition efficiency, in case of the nickel, the inhibition efficiency is 1.66, and in case of the sulfapyridine is around 1.49. So it means that after the nickel complexation, the inhibition efficiency is increases. From the molecular population analysis, oxygen and nitrogen from the SO2 moiety as well as the amide group have the more negative in the nature compared to the reported data, as well as from the NVO analysis, carbon from the amide benzene ring and carbon from the free solvent molecule, as well as in this structure the nickel also play a major role in the molecule stability from the NVO analysis. So from the theoretical analysis, we know that after the complexes, the effectivity is also increases and stability is also increases. So now we get out the biological activity, and from the UV visible absorption fraction, the Kb value from the nickel complex is 4.1, and in case of the sulfapyridine molecule is 1.2. So the standard drug that already available in the market that have the Kb value is 1.2, and metal complex is 4.1. So after complexation, the DNA binding interaction is increases. And also compare with the reported data of cadmium sulfapyridine as well as the Zn sulfapyridine, and it's far lesser than the nickel complex of sulfapyridine molecule. This is molecular docking study, and from the molecular docking study, that one is from the metal and that one is from the sulfapyridine molecule. So it's more negative, it means that more binding affinity compared to the sulfapyridine molecule. Viscosity method, the curve graph show that the binding is between the DNA to metal is intercalation, and from the cytotoxicity, the toxicity of the nickel is 7.44, and in case of the free sulfapyridine is 11.35. So it means that after complex of the nickel, the toxicity is drastically reduced. Minimum inhibition concentration, from the data we can say that in case of the metal we need a less amount to kill the bacteria compared to the sulfapyridine molecule, and same in the cell viability study. Chapter 5, silver complex of sulfapyridine in presence of the tetrahedral pyrrole. So in the previous chapter we used the nickel, and in this chapter we use the silver as our target aim. So synthesis process are same that we discussed in the previous chapter. From the spectroscopy characterization, that peak is absent around 10.97 is 10.97 present in the case of the sulfapyridine molecule, are absent in the case of the metal complex of sulfapyridine. So we saw that SO2 NH moiety is deprotonated. From the FTI spectroscopy, some vibration are present in case of sulfapyridine molecule, and in case of the nickel sulfapyridine molecule, that same vibration are absent, so it means that the metal is there. This is a few symmetry and asymmetry vibration. X-ray crystallographic investigation, the silver complex of sulfapyridine are crystalline in monoclinic crystal system with the P2 1 by N space group. And there is one thing is goodness of fit. This value is around 1.0. Whenever the goodness of fit around 1.0, it means that the structure are well refined and there is no atom is left, no residue is left to solve. And in this silver complex of sulfapyridine, that molecule are 2D framework, that for the MOF. We also call that MOF, metal organic framework. So here that structure is a 2-dimension. Here the 2 silver is taking part in the coordination. And the 1 silver is coordinated with the NS2 group, NS2 group as well as the NS group, and 1 silver is only coordinated with the NS group. So that's why the 1 silver atom form the pentadental geometry, and second one form the tetradental geometry with the argentophilic interaction is around 2.96. This is the diagonal angle and torsional angle. Now in case of the metal is around 80.57, and in case of the free ligand is 84.016, means that the diagonal angle decreases after the complexation. Inter-intermolecular interaction. Here the NH2 molecule interact with the oxygen from the SO2 moiety that form the R2 by 2 8 graph cell moiety, and this is how that beautiful way is aligned in the unit cell. Second is a CH pi interaction. CH pi happen between the carbon from the THF solvent molecule and interact with the pyridine ring. And in case of the pi interaction, the pi interaction is happen between the ring that bind with the metal that called the pyridine ring and amide ring, and both the ring are interact to each other via the CH pi interaction. This is 4.22. There is a few intra and intermolecular interaction. In this case also the CHO interaction are playing a dominant role in the molecule stability, as well as the one interesting thing is that this sulfur molecule S1 from the SO2 group also now taking part in the intra and intermolecular interaction. From the Hertz sub-analysis, the red dots surrounded by the amide group and surrounding by the SO2 moiety, as well as the surrounding by the tetrahydropyrrole are the more negative cloud. And from the DSR we know that that nitrogen play NH2 group play as a donor in nature, and that one thing is that from here you can see that the red dot is surrounded by the silver atom. So silver atom also is taking part as an acceptor. It's not a bind, but it's interactions with the donor atom. In case of the SAP index, that red and blue triangle surrounding by the amide group, as well as that solvent molecule, that both are playing in the CH pi interaction. From the 2D figure we plot here the CH pi, that is contribution of H to C. In case of the sulfur pyridine is 50.5, and in case of the silver sulfur pyridine is 20.5. Now here that polymeric chain formed between the NH2 group to the oxygen group are confirmed by the interaction between the silver to nitrogen is 1.1. So the polymeric chain is also confirmed using the 2D figure plot. And in every case the hydrogen interaction are more compared to the free sulfur pyridine, and this is because of the structure function relation, right? If the structure function relation is changed, then hydrogen interaction, hydrogen to carbon interaction are changed. From the lipophilicity, the data show that the silver have the more lipophilic in nature compared to the sulfur pyridine molecule. And from the void study, we can say that the silver sulfur pyridine are not have that much porosity compared to the sulfur pyridine molecule, and that is because of in previous chapter only one metal taking part in the binding, but here in the case of the silver there is a two metal is there, so porosity is reduced because of maybe the extra atom is present in the lattice. The energy framework analysis. From the energy framework analysis, NHO interaction are play a dominant role in the molecule stability compared to another interaction, and this is the Coulomb energy, dispersive energy, and total energy. And that tube, if the tube is big in size, it means that the interaction strength are more compared to if this tube is less in the size. And this is a few interaction. Molecular MEP, from the MEP, the oxygen from the SO2 moiety as well as the nitrogen from the pyridine ring and metal have the negative cloud, and rest of the carbon molecule surrounding by the solvent molecule as well as surrounding by the pyridine molecule have the positive charge. Homolum energy, from the homolum energy, here the band gap in case of the sulfur pyridine molecule is 4.4, and in case of the silver sulfur pyridine is 4.51. So now here in this case the sulfur pyridine molecule are soft in the nature. The value is not more, the difference is not more, but from the data we can say that the sulfur pyridine molecule are soft in nature compared to the silver sulfur pyridine molecule, as well as in the hardness studies that silver is more hard compared to the sulfur pyridine molecule, and that is because of some literature surveys show that whenever the 2 or 3 metal are coming into picture, then hardness of the molecule also increases. And the minimum inhibition, maximum charge transfer. From the maximum charge transfer, in case of the silver is 1.1, and in case of the free sulfur pyridine is 1.45. From the molecule, as we discussed in the previous chapter, the nitrogen from the amido group as well as the nitrogen from the pyridine group have the more negative in the nature, and oxygen from the SO2 moiety also have the more negative in the nature compared to the another data, and highly charged surrounding by the sulfur molecule. And from the NV analysis, the carbon from the NH2 ring have or play the dominant role in the molecule stability, as well as the silver atom also play the noticeable role in the molecule stability with the values of energies around 50.58, 43.42 and 12.8 kilocalorie per mole. Biological activity, the UV visible spectroscope suggests that the in case Kb value in case of the metal is around 1.5, and in case of the sulfapyridine molecule is 1.2. So the metal show more binding affinity compared to the sulfapyridine molecule. From the viscosity analysis, the curve graph shows that the intercalation binding happen between the DNA to the metal complexes, and the same that we are present in the 2D figure plot. From the cytotoxicity, the toxicity of the silver complexes of sulfapyridine is 11.35. Now, in case of metal silver complex of sulfapyridine is 6.15, and in case of the sulfapyridine molecule is 11.35. So the silver is less toxic in the nature compared to the sulfapyridine molecule. From the minimum inhibition concentration, the silver complex of sulfapyridine require the less amount to inhibit the bacteria compared to the sulfapyridine molecule, and the same thing that is happening in the case of the cell viability studies. From the molecule docking study, the docking energy in the case of sulfapyridine molecule is 173, and in case of the silver sulfapyridine is around 192. So the silver complex of sulfapyridine molecule have the more binding strength compared to the sulfapyridine molecule. Chapter 6, silver complex of sulfadiazine depends on the 3-methyl pyridine. Synthesis process the same that we discussed in the previous chapter, but here I take the 2:2 ratio. This is a 1 NMR spectroscopy. The peak is absent in the case of the metal, is suggests that the metal is now binding with the nitrogen atom, and the same thing in the FTI spectroscopy. Some vibrations are present in the case of sulfapyridine molecule, and that same vibrations are absent in the case of the metal complex. That is such that the deprotonation of NH2 amine moiety. There is a few theoretical vibrations. X-ray crystallographic analysis. X-ray crystallography analysis suggests that it crystallizes the monoclinic crystal system with the P2-1/C space group. Here, the one silver atom have the penta-delta geometry, and second one is the tetra-delta geometry. Here, the very interesting thing is that in previous chapter the one molecule per symmetry unit. In this case, the two molecules are taking part in the symmetry unit. The dihedral angle between the amido group and dihedral in between the diazine moiety is around 7. Sorry, the angle between the two pseudo ring, the pseudo ring happening between the Ag1, Ag2, N2, C7, and N3 is around 7.31. Dihedral angle between the amine ring and dihedral angle between molecule A and molecule B is around 89.47 in case of the molecule 1, and in case of the molecule 2 is 88.10, because that is a 2 molecule per symmetry unit. Inter and intermolecular interaction. Here, the nitrogen from the NH2 group as well as the carbon from that ring are taking part in the inter and intermolecular interaction, and that form the R2-1/6 graph-set model, and there is another graph-set model is there, R1/2, R2/2, and R2/6 graph-set model. And second, in case of this, here the nitrogen from the amide group are interact with the pyridine that moiety, and second oxygen from the SO2 moiety interact with that nitrogen, and that form the R2/2 graph-set motif, and because of that graph-set motif, that all the atoms are aligned in the unit cell. The inter and intermolecular interaction. Now in the previous chapter we know that the CHO interaction play the dominant role in the previous chapter, but in case of the silver complexes of a diazine, here the nitrogen molecule from the NH2 group are play a major role in the molecule stability and molecule packing. Why? Because in this case there is a 2 molecule per symmetry unit, so there is a 2 NH2 group in this case. At the same time, there is a CH pi interaction are more compared to that previous chapter, and yes, the CH pi interaction happened between the pyridine ring and amide group, and same the pi pi interaction happened between the amide group and pyridine ring. So pyridine ring and amide group, they both are taking part in the CH pi and pi pi interaction. From the herpes analysis, the red dots surrounding by the NH2 group the lesser than the van der Waals interaction. From the DI surface analysis, we know that in this surface from the DI, there is a lot of the red dot is there. So that molecule, in this molecule, most of the atom are playing a dominant role toward the as a donor. Now in case of the D, there is a less acceptor side. Okay. From the step index, we know that the pi pi and CH pi interaction. From the 2D finger plot, In this case, also the CH pi interaction is more in case of the silver sulfur diazine, and hydrogen hydrogen is also more in case of the silver sulfur diazine molecule. From the lipophilicity in case of the metal is more compared to the diazine molecule, and the porosity in case of silver sulfur diazine is 12.90, and in case of the free ligand is around 8.8. Energy framework. Here the NHO, CHN and CHO have the more dispersed energy compared to the another interaction. That interaction also play a major role in the molecule stability, and there is few interactions with that energy are shown in the figure. From the electrostatic potential, the negative cloud is surrounded by the oxygen molecule and also the nitrogen molecule. From the homology energy, band gap in case of the diazine molecule is 4.6, and in case of the silver diazine molecule is 3.8. So it means that in case of the metal is soft in the nature compared to the diazine molecule, and at the same time the hardness of the silver sulfur diazine is less compared to the diazine molecule. And inhibition efficiency, the inhibition efficiency of the silver complex of sulfur diazine molecule is 1.45, and in case of the diazine molecule is 1.4. So it means that the metal complexes are more inhibition in nature compared to the diazine molecule. From the molecular properties analysis, nitrogen and oxygen are the more negative in nature, and from the NB analysis, the carbon from the amino group as well as the carbon from the pyridine ring also taking part in the molecule stability, as well as both the silver atom in this structure are play a dominant role in the molecule stability. From the UV visible spectroscopy, in case of Kb value in case of the diazine molecule is around 1.07, and in case of the silver sulfur diazine molecule is 1.54. So it means that the binding affinity of the silver complex of sulfur diazine are more compared to the diazine molecule. From the visible spectroscopy, the curve graph suggests that the interaction happen between the DNA to the metal complexes are intercalcium mode. And cytotoxicity, the metal complexes are less toxic in the nature compared to the diazine molecule. Minimum inhibition concentration. See in the figure, in case of the metal, we require the less amount of the compound to inhibit the bacteria compared to the diazine molecule. Molecule Dawkins list suggests that in case of the sulfur diazine molecule is around minus 0.72, and in case of the diazine, silver sulfur diazine is around 292 minus. So it means that the silver complex are more silver complex have the more binding strength compared to the diazine molecule. Chapter 7, silver complex of sulfur methoxazole. Synthesis process is same. One is satisfied spectroscopy, that one peak is absent around the 10.92, that suggests that the metal is binding. Same case in the FTR spectroscopy, there is a few vibration. Crystallographic analysis, this lies in the monoglyph phase group with the C2C by phase group, and here that molecule also form the one-dimension polymeric chain. Here the one silver is from the pentadendral geometry, and that interact with the NH, and that line is from the one-dimension polymeric chain, and also the one-dimension metal organic framework. So now it is a diagonal again. Here also the two molecule or symmetric molecule. So one molecule has the diagonal around 8.553, and in case of the molecule B is around 8, sorry, not around but exact at 3.66. Inter-molecule interaction. Here is the same. The nitrogen from the amido group also taking part in the NHO interaction, and the same the second nitrogen from second molecule also taking part in the NHO interaction, and that the interaction form the R2 by 220 graphic motif, and also the same nitrogen also interact with the oxygen from the SO2 group to form the one-dimension interaction chain. And also here the solvent molecule are taking part in the CH pi interaction via the methoxazole ring, and carbon from the THFC26 are responsible for the CH pi interaction. Also the pi interaction is present in that case. The pi interaction happen between the amide ring from the NH2 group, and as well as second pi ring is coming from the methoxazole ring. Surface analysis, the red dot is surrounded by the NH2, and as well as the red dot surrounded by the metal that have the distance lesser than the van der Waals interaction. Two-dimensional fingertip plot. Here, the hydrogen interaction are more in case of the SMX, more in case of the silver SMX compared to the SMX molecule. Lipophilicity, the lipophilicity in case of the metal is 2.85, in case of the silver is around 3.40, and the void study suggests that in case of the silver is around 13.717, and in case of free SMX is 10.22. Molecular electrostatic potential. Here the negative cloud surrounded by the SO2 group as well as the surrounded by the free solvent molecule and nitrogen from the NH group. Homolome energy, the band gap in case of the SMX ligand is 5.11, and in case of the metal is around 4.36. So that data suggests that our molecule is soft in the nature, as well as that reactivity of the molecule, metal molecule, are more compared to the reported SMX or that standard drug. And in case of the inhibition efficiency, the inhibition efficiency in case of the metal is around 1.37, and in case of the free ligand is 1.3. So the synthesized metal complex are more inhibition in nature compared to the SMX molecule. Molecule population, the nitrogen from the amide group, as well as nitrogen from the methoxazole group, and 2 oxygen from the SO2 moiety, and 1 oxygen from the methoxazole group have the more negative charge. And from the NBO analysis, sulfur, here very interesting thing is that sulfur play the major role in the molecule stability by C1, H1 and C1 and 2, as well as the metal also taking part in the molecule stability. From the usable spectroscopy, the binding capability in case of the SMX is 5.6, and very interesting thing is that in this structure, this is the highest binding affinity compared to all the reported data that available in market. And also compared with the copper sulfur dimethoxy and silver sulfur dimethoxy is 1.3 and 1.8. So this is the highest binding affinity in case of the AgSMX, and this is maybe because of that 2 sulfur are taking part. The 2 sulfur is present on that molecule, and sulfur have the charge higher compared to the another atom. So maybe that taking part in the interaction more compared to the another atom. Here, see in the case of the AgSMX, the graph is increasing in nature, but in case of the SMX, graph is straight. So it's mean that SMX don't have the intercalation bindings, right, compared to the AgSMX, because AgSMX is increasing nature. So AgSMX have the more intercalation binding more compared to the SMX molecule. And from the cytotoxicity, the toxicity of the metal is 6.30, and in case of the metal is 12.88. So the synthesized complex is less toxic in nature compared to the SMX. Minimum inhibition concentration such that we require the less concentration to kill the bacteria in case of in case of the AgSMX compared to SMX molecule. From the docking study, the docking score of metal complex is around -3.19, and in case of the SMX is -223. So the silver complex of SMX have the more binding affinity compared to SMX. Okay. Chapter 8, silver complex of sulfur fluoropyridine in case of in presence of sulfur pyridine molecule and dihydrogen molecule. Synthesis process is same, but the proportion is different. Spectroscopy, 1H NMR spectroscopy, the peak is absent in the that I not present here, the sulfur fluoropyridine NMR, but the NS peak is absent. It means that the metal is now binding with the nitrogen atom. X-ray crystallography analysis to crystallize in the monoclinic space group with the P21 by N, and here the one free solar molecule also present in the lattice, as well at the same time the 2 S2 molecule, water is also present in the lattice. Now what is the role of the S2 we also discussed. Here the one here the 2 silver atoms are connect with each other via the agentophilic interaction. The hand angle between the 2 rings is around 74.01 in case of silver sulfur chloropyridine, and in case of the free sulfur chloropyridine around 82.86. So it means that after the coordination of the silver, the dihedral angle decreases, and the dihedral angle between the 2 pseudo ring is around 0.02. So both are the planar in nature. Inter and intermolecular interaction, the NHO interaction and CHO has the same in case of the intermolecular interaction, and in case of the intermolecular interaction, the NHO play the dominant role. Now pi-pi interaction, the pi-pi interaction happen between the 2 chloropyridine ring. So here, in this case, that is no role of amide group in the CH pi and pi-pi interaction. And in case of the Herpes-Sulfur analysis, now in this structure the chlorine is there, right? So in the last, the chlorine have the large area of the red dot. So it means that whenever that molecule is interacted with the biomolecule, the chlorine also play a dominant role to interact with the biomolecule. 2D fingerprint plot. In this case also, the hydrogen interaction are more in case of the silver sulfur chloropyridine compared to the chloropyridine molecule, as well as the CH pi interaction are more compared to the chloropyridine molecule. In this case, I have not carried out the DFT study because of the solvent is there, so that's why it is not stabilized, it is not optimized in the DFT. So I don't carry out the DFT studies. But from the UV visible spectroscopy, we can say that in case of Kb value in case of the silver sulfur chlorophyll is around 2.08, and in case of the chlorophyll is 1.4. So binding affinity or binding strength after the complexation is more compared to the chlorophyll molecule. Viscosity analysis say that both are in the intercorrelation mode. And cytotoxicity, the toxicity of the metal is less compared to the chlorophyll molecule. Minimum inhibition concentration, we require the less amount of the concentration to stop or to kill the bacteria compared to the sulfur chlorophyll molecule. From the molecular docking studies, the binding energy in case of the silver is high compared to the sulfur chlorophyll molecule. So the more binding in nature compared to the sulfur chlorophyll molecule. So now the conclusion. So our conclusion are divided in two parts. One conclusion part A is comparison between our synthesized molecule, and part B is comparison with the recorded data. So preliminary crystallographic data, most all the molecules are crystalline in the monoclinic space group. Sorry, monoclinic is a system. The comparison based on the coordination geometry. Here, in the case of the copper complexes of a dimethoxy molecule, that copper has octahedral geometry in case of the nickels and octahedral geometry. But in case of the silver sulfur PD, because of that polymeric chain, the one silver atom has the triangular geometry and second one has the tetrahedral geometry. And in case of the silver sulfur dimethoxy molecule, 6-1, same that we have in the AgSQX. And in case of the AgSMX, that has the tetrahedral geometry, and in case of the sulfur chlorophyll it have tetrahedral geometry. This is the bond and bond angle combination. 2D finger report. From this data, we can say that in case of nickel sulfur pairing, it is 56.1, and it is higher compared to all the synthesized molecule. And in case of the CH pi interaction, the CH pi interaction are more in case of the copper sulfur dimethoxy molecule compared to the another metal molecule. In void, 25.56. That is coming from silver complex of sulfur chlorophyll molecule. So void are more in case of the silver complex of sulfur chlorophyll molecule. Lipophilicity, the silver complex of sulfur PD have the the copper complex of sulfur dimethoxy have the 3.64. So it means that in presence of copper, the complex are more lipophilic in nature. Quantum chemical calculation, from the data we can say that the band gap in case of the copper sulfur dimethoxy is 3 and is lesser than all the synthesized molecules. So the copper sulfur dimethoxy have the soft in the nature, and at the same time inhibition efficiency of that copper is also high compared to all the synthesized molecule. Biological activity, the DNA binding study. Now in case of the DNA binding study, the silver complex of SMX have the more binding in nature compared to all the metal complexes, and all the molecules, synthesized molecule have the pi stacking interaction with the ctDNA. Cytotoxicity, in case of the toxicity, the copper have the lesser toxicity compared to all the recorded data. From the minimum inhibition concentration, in case of the positive bacteria, silver complex of sulfur chlorophyll have or maybe require the less concentration to stop or kill the growth of the bacteria. And in case of the negative, silver complex sulfur diazine have the more, require the less amount to kill the bacteria. From the docking studies, the sulfur chlorophyll have the more negative, so it's more binding affinity. Part B, comparing the recorded data. In case of this copper complex of sulfur dimethoxy, compared with the copper complex of succinate sulfur thiazole, and compared with the copper complex of sulfur methazine, have the pentadentate and octahedral geometry. And this is the bond length and bond angle. So after coordination of silver, the bond angle and bond also changes. 2D fingerprint plot compared with that copper complex of succinate sulfur thiazole and copper complex of sulfur methazine. The copper complex of sulfur diazine that I synthesized in my laboratory have the more docking score, the less toxicity, and require the lesser amount to kill the bacteria compared to the reported data. Chapter 4, the nickel complex of sulfur pairing. I compare with the nickel complex of sulfur diazine and nickel complex of sulfur methazole. All are in the octahedral geometry. 2D fingerprint plot. In case of nickel complex of sulfur PD that I synthesized in my laboratory, that have the more hydrogen interaction compared to the reported data, as well as in case of the hydrogen to oxygen, like also compared to is more compared to in case of sulfur diazine molecule, but very much similar compared to the sulfur mathazine molecule. And second, the CH5 interaction. Now, in case of the CH5 interaction, in case of not my but nickel complex sulfur-pyridine synthesized molecule has the more CH5 interaction compared to the reported data. Chapter 5, 6, and 7. Why I compare all the data? Because all the chapter carried out the silver as my main target. So here most of the reported data in my complex have the monoclinic system and have the tetrahedral pentagonal geometry. Comparison study in case of the silver sulfur SMX, right, have the more hydrogen interaction. Now this is very interesting here. The 53.5, and we discussed in that DNA interaction study that highest KB value is coming from the AGSMX. At the same time, the highest HA interaction in case of the AGSMX are more. So that's why we correlate that theoretical or crystallography with the biological activity. Now, in case of the DNA interaction study, we know that AGSMX have the more DNA binding affinity compared to the reported data, and also at the same time, AGSMX have the more lipophilic in nature. So solubility of AGSMX in the polar solvent theoretically are more in case of AGSMX compared to the reported data as well as my synthesized molecule. So this is a few research paper, book, list of the conference. Oh, that's future plan. Okay. So ये जो मैंने क्रिस्टल जो माउंट किया है ना, ये मैंने माउंट किया ड्यूरिंग माय PhD. This is beauty of crystallography. This one is very beautiful. And this is a crystallization, right? Thank you.
But anyway, Bhavesh, you have done a lot of work, a lot of good work and extensive work. So, I'm doing 5, maybe 2, 5, 6 structures. I'm going to through the extensive kind of work where you've done computational, experimental, biological evaluation. Generally, everybody does not do so much of this. See. So, my first thing is, since this is your Viva, you have all monoclinic complexes here of crystal systems. What about the crystal system where the metal line was not there? Are they also monoclinic? This is just out of interest.
No. Now, in case of the hydrazide molecule, right? I see that most of the hydrazide molecule have the orthorhombic crystal system. Now, in case of the silver sulfur mathazine that I present in my MPhil work, that have the orthorhombic system with PBCS PhD.
So, I think all the metal led to the dimerization of all your molecules because of the coordination. So, it had dimerization of all the molecules.
Yes.
So, there is also another thing that when you were docking the compounds, your orientation of docking of the compound without the metal ion and with the metal ion, all the places were different. How do you perceive that? Because when I looked at that with the docking, I saw that the metal, your sulfamides without the metal ion were docking in a certain position, whereas they were not integrating, but they were like they are the base pairs. But when you go and see your dimerized molecules containing a metal ion, they were always binding mostly as a major.
Major that ring.
No, you see that groove here, no?
No.
So when you look at, you can put one of them. Show one of them, any one of them. So when you look at this is actually, and there is another thing, you look at it, your base pairs are distorted over here. And this एक बार मैं zoom मैं खड़े होके बताऊं ये वाला. So this is going and binding near the base pairs, है ना? Now you go to the other one. other one,
other
the
बीजू
dimerization.
बाजू में छे
हाँ
Supra reduced the so this is not binding at that position, this is binding at another position.
different
Different position. So this when you see these are the major and the minor groups. So in this case it is bound to the minor group, it's not that the major group is the one downstairs. And how did you decide the length of the DNA? Is it known or
मैम ये सीधा मैंने डाउनलोड किया है पीडीबी से
अच्छा उसका एक तो you make किया है? अच्छा.
पीडीबी मैंने डाउनलोड किया फ्रॉम द पीडीबी
So my question is why? ये तुमने सोचा?
maybe this is because of when metal is there ना तो उसका जो confirmation is ना totally change हो जाता है right at the same time there is ना space void okay so if the DNA have the more void then
No. More void यहाँ पे नहीं आएगा Bhavesh because now I'm talking biology. ठीक है? So it does not come in this. More void इसलिए नहीं आएगा because you've taken a certain DNA and you're using that for talking. That confirmation you have not changed. So more void will only come in if you do what is known as molecular dynamic simulation, which is not done in this. So what I feel is it is binding to that place and here in the minor group or in the. So if you see a small, this is BDNA as far as I can see.
CTDNA yes
CTDNA.
that is CT.
So that is BDNA. So here if you see these two groups, the upper one is minor, the lower one is major. So why it is binding here is because it is too big for it to go and integrate into the base. So that is why it is changing its position. Now when you talk about LUMO and HUMO, your gap between the LUMO and the HUMO was decreasing. What does that mean?
डी ना ऊपर हॉस्टल
D.
सर्विस
You spoke about soft, you spoke about
Achha.
hardness.
from this
है ना? अब मैं biological term में पूछूं. What does it mean? And it's not like chemistry.
so it's chemically soft and chemically hard if it is soft it's
When
means
the gap reduces, what does LUMO and HUMO donate?
if the band gap is reduces it means that molecule require less energy to interact with the
So it can not interact. Charge transfer
Charge transfer.
is faster
Faster.
and it can occur more easily because the gap is decreased. So that is why it is coming. So actually I learned something new. I didn't know about this soft and hard. We have always talked in terms of charge transfer when we talk about HUMO and HUMO. Because these are the molecule orbitals.
Molecule.
The highest energy.
molecule orbit and lower energy.
My space group though, I was just wondering why all of them are monoclinic when I was reading the thesis. But I could not answer that question myself because anyway that is crystallography beauty. Crystallography impact. Okay, one you said dihedral angles and torsion angles. So I was just wondering what according to you is the difference between them?
Diagonal so when diagonal angle the diagonal angle is out between the diagonal between the I selected two ring one from the MID group and second one from the another pyrimidine ring and I calculate the diagonal that is a plane one and second and angle between
This is the
the
angle between the
two planes.
for dihedral.
Right.
For torsion, what
Torsion angle I select in case of this one there is a lot of torsion is there but I select the few I present in my thesis I select the 5 one and why I select the 5 one because the metal is coming with that nitrogen so metal is there in that case the that torsion angle is changed so I calculate this one in case of the free ligand and after the binding of the metal the torsion angle is changed or not so this is
in nickel, actually
the
always
torsion angle is about a bond.
about the
Okay, you have to select three, always three atom makes the plane.
four
No, 1, 2, 3,
Achha.
and 2, 3, 4.
C1 S1
First you calculate a plane of 1, 2, 3,
1, 2, 3.
then another one you calculate 2, 3, 4 atom. Now when you calculate the angle between this 1, 2, 3 and 2, 3, 4, then it is becoming angle between this bond. This is 2, this is 3, there is a 4, there is 1. Okay, so if 1, 2, you can calculate a plane equation by 1, 2, 3, another plane equation by 2, 3, 4. Once you calculate the angle, then it will be about a bond. You can calculate that angle torsional,
Torsional. Bending.
bending, or torsional twisting. About any bond you can calculate. Huh? But interesting is which bond is changing your molecular conformation. You are concentrated on that. Because if you open that Winjex file, there will be thousands of
torsional is there. I select the few, and that is depending on based on the metal.
And diagonal angle is angle between any two planes.
Diagonal angle between the two.
So both of them are responsible for molecular conformation and molecular configuration.
मुझे दो terms बोल दिए. Now you are in trouble. Conformation and configuration. What is the difference?
Conformation.
And configuration.
Conformation is known that how is changed. That is a conformation. Whenever the metal is there, then torsional is changed. So this is a conformation of metal.
And configuration क्या होता है?
Configuration one is depends on the problem.
See, what we teach our students, conformation is a change which does not occur without the breaking any bond or removing atoms. But when you talk about configuration, a bond has to be broken. Okay. So if any bond is broken and then your structure changes, that is configuration. But if the change occurs without breaking the bond, or just like you say a torsional angle change or a dihedral change, then it is conformation.
So I have the configuration.
You have conformational. You don't have
There are
configuration.
Bond is breaking.
Where is it breaking?
NH is
Not breaking, changing, it is twisting.
It is twisting.
It is twisting.
Break means actually physically break. You have to physically break the bond. Okay. So you have shown that there are structural changes. What was the extent of the structural change between your metal binding in the molecule where you had the metal binding and the latex molecule without the metal binding? You get those structures also known. See what you have compared with all the metal binding, the sulfurs which have a metal, but you have not compared with the latex. So I was just wondering how drastic is the structural change, because earlier whatever the structure was, not just interacting with the metal ion and then it is forming a dimer. So does this basic structure also change? Does this? It's not changed. That remains the same. So then why are you seeing this conformational and torsional angle differences? Because at least there's a structural change.
वो डायहैंडल का जो मैंने कंपैरिजन किया ना, वो आफ्टर मेटल बिफोर मेटल क्या चेंज आ रहा है?
हाँ, यही इसका मतलब है चेंज.
हाँ, मतलब only for the ligand that diagonal angle is around
नहीं, ligand तो as a ligand you are talking, when you are saying ligand you are meaning your sulfur drug. So basically there is a structural change.
Molecular dimension does not change.
The dimension is not.
Conformation changes. And conformation changes because metal coordinates over there. The moment metal comes, there is a heavy atom. So because of the heavy atom, it is going, and there is a coordination covalent bond. Covalent and but it is there no within 3 angstrom. So everything within 3 angstrom, it is going to affect your molecular.
Do you remember the question which I actually asked? अच्छा हाँ, ये तो मैं वैसे ही पूछने वाली थी. You have compared all of them, all your structures finally, and when you look at individually, each one of them has a property which is more favorable. But out of all these 6 compounds, first, which one do you think is a better ion? Copper, nickel, silver. So then out of these 4 compounds which you made, 1, 2, 4 here, which is the best one?
Silver is sulfur nickel.
And can you think why in all the others, when you were having the dimer formation, only one metal was binding in the case of copper and nickel. But when you are having silver, each time you have 2 silver atoms, no?
Yes, argentopyrite interaction. You are having two silver is coming together.
So why is that so? Is it because of the coordination of the?
Because of there are two molecule per asymmetric unit every time. You see, in case of copper and nickel, there are not two molecule per asymmetric unit. In case of silver, there are always two molecule per asymmetric unit. The moment two molecule is there, it's compact, and molecular dimension is as it was. It's not so big. So how it will manage over there in that small space?
Basically, your unit cell parameters are not changing much.
It's like two molecules come very close together, and the moment it comes, AGAG interactions are there. If there is only one silver molecule, no, then it might be or may not be, I doubt. But since there are two molecule per asymmetric unit, so to manage the space, ideally,
In case of the silver sulfur PV,
It is
there is one symmetry unit. In case of the silver sulfur PV, there is one symmetry unit.
No. She's talking about the way it is interacting.
Sir is
and
saying, madam is saying that.
the way, so she's explaining why they are interacting like this. The question which I have asked. And how it is occurring, how it is that compact structure is getting accommodated in this unit cell.
Accommodation of the
इसको नहीं समझ में आया क्या बोला अब आया समझ में what I was talking about
Because of the symmetry unit.
ठीक है चलो I think I don't have any more.
Ashok, please come.
अशोक यहाँ बैठो यार
Please.
I just want to know, see, normally DFT calculations, we don't really directly talk about bioaffinity and all. So how you basically want to correlate through DFT the bioaffinity? Purely through correlation coefficient or?
So first of all, when I start the DFT, first I optimize the structure.
Yeah.
From the optimization, if the bond and bond and from the theoretical data, if it is very much similar with the experimental data, then I go for the DFT study, hormonal energy and the NBO. If it is the correlation coefficient is not near to the one, then that means that structure is not well optimized. So if further we go on, then the DFT, the calculation is totally wrong. So
Yeah, but
this-
how to correlate that is with the biological activity.
from the global quantum parameter, the global quantum parameter say that like electrophilicity, electronegativity, inhibition efficiency, that all are questions from the hormonal energy. So I use that parameter, and that parameter suggests that if the value is high in case of the delta n, it means that the more inhibition is nature. So
You can predict something
Predict,
from those
this is
data.
totally prediction.
And selection of the target molecule for the protein interaction also you can select like that. Because you can get some electrophilicity, electronegativity, hardness, softness, and those parameters are very helpful to know your molecular property of your molecule. So from that you can select your target molecule on the receptor side. You have done ctDNA is okay because it is available, but you can change also ctDNA. You can change if it is
certain
available.
the correlation coefficient is not exactly 1. It's maybe the 0.98, and that is because
So
of
there
that
is near
no
to-
intermolecular
near
is there in the case of the DFT.
Why you considered for that relation this gas phase?
Why it is called gas phase?
Gas phase.
Because in case of the DFT,
Though the molecule is your single crystal.
single crystal molecule have the
Because
interaction.
students are also there,
Huh.
right? So
So why I said it, because whenever we talking about the function that called the force field, in that case, in the case of the force field, there is no parameter of the interaction, there is no parameter of the temperature. So if the temperature is there, if the interaction is there, then maybe the correlation coefficient is different, maybe that effectivity is also different. So in the case of the DFT, there is no that extra coefficient are entering in the force field. But whenever we discuss the molecular dynamics, in case of the molecular dynamics, there is a parameter that to the temperature, but in that case also there is no interaction parameter is involved in the force field equation. So
I think how much I know. We are taking the data, raw data for DFT from our X-ray study. That is our CIF file. Okay, and that file is you can say it is dynamic because we are seeing all interatomic interaction and everything. But the moment he goes to DFT study, in that program there is no provision to calculate all those intermolecular interaction and all.
It is more of a 2D.
It is dead. Think that they are dead now. Though it is there in X-ray we got, but now we cannot see them in our DFT study because we cannot use it. So in absence of those interactions, we have to do the calculation. Follow? Because it is a program limitation. It is a limitation of the program. So we call it as a gas phase. And in the absence of interaction, you can think so many things. यहाँ interaction ना हो तो आप only situation विचार करो. यहाँ interaction छे એટલે आप only situation विचार करो. बराबर ना? It's like it's becoming something you can calculate.
And there is also a limitation of number of
Limitation of
atoms
the-
which you can consider in your system.
No, program
also I select that restriction
atoms
parameter.
are all selected. Because we don't remove. Otherwise the
PFT calculation for proteins also.
Huh.
Where
But
that
उसका
requires,
program may be different. You have done in Schrodinger.
where that requires
Schrodinger and
a
Gaussian.
lot.
आपने Schrodinger में
So
करा.
we can so many questions like that.
So that is DFT with Schrodinger.
So there are maybe
But only
provisions.
time requirement is
Very much more.
No, no. While I was getting retired, we got a workstation, but that workstation we could not use it. If we could have workstation, then we can do the longer time calculation. So we can inhabit all those parameters. One by one, you keep on including those parameters, so you can do the calculation. But एक stage में we did this calculation, one step. Remove everything, and as he said, thermal parameter and all that consideration we are not doing. Otherwise, we can do it. But this single crystal is also at room temperature only. हमें जो 3D करियो छे, we have done the 3D structure in room temperature. We collected the data on room temperature with our machine. There is a provision in our machine that we can go to low temperature also. But there are so many things કરી શકીએ છે, પણ કરી નહીં શકતા. This is like that. So think of it. And with this, there is a corona period of 2 years. And then I got retired. A machine also got retired. Problem. There are
That's a
problems.
good one. I won't get that machine also.
Machine got retired. Before I have my retirement card account from university, my machine started thinking of its life, no? But still, you can guess something and you can think of something. You can think the power of single crystal, except solarity. That is important. Because this type of calculations you can do only with the help of except solarity. I hope those who are working, otherwise not possible. You don't get so many data. Yeah, no?
Lastly,
Madam.
Madam has already
Madam has-
asked that so many
Madam,
metal
Madam,
complexes
Madam.
which integrated and you compared it, and each one has certain beauties and all that, right? So can you see? You say that one of them is the best, but then each one has their domain beauty. So that statement also would have helped.
Yes.
That this one is good for this type of biological activity, other one is for other, like that. Can you
Yes, yes.
make that final
Yes.
statement?
From starting from the DNA interaction study, from the DNA we know that the silver complexes of methyl have the more DNA bindings. But in case of the cytotoxicity, the copper sulfur dimethyl has the lower toxicity compared to AGSL. Only AGSL has a more binding affinity, but in case of the toxicity, silver is better. Right? Now, in case of the minimum inhibition concentration, right? In that minimum inhibition concentration, the silver complex of sulfur chloropyrin require the less concentration to stop or to give the bacterial growth. But at the same time, the silver complex of sulfur chloropyrin don't have the more DNA binding study as well as the toxicity is increased more compared to the copper sulfur. Copper sulfur dimethyl. And secondly, in the case of the nickel also highest DNA binding study, but at the same time toxicity also increased with the DNA binding study.
So I think he has done only with two comparisons.
Yes.
Cytotoxicity, looking towards cytotoxicity and then MIC. But that's not the can do still more statistics. Otherwise, we cannot select that drug. It is only 6 molecule, and then once again only 3 silver molecule, and once again the ligand is different. Sulfachlorobiodazine, sulfadiazine, sulfapyridine. There are a lot of variations. This is the conclusion, but this conclusion is not very good conclusion. But for the thesis is okay. For thesis point of view, it is okay. But you
This is
cannot
not the
conclude
end
like
of the
that.
world. That is
This
the
is not
beginning.
right. It is the
So he already said he has some future plans.
Yeah, so many.
So many parameters.
So then just
Because just cytotoxicity
means towards an
is
end, which will start now.
So new problems are emerging for the next one. Thank you.
Anyone?
Anyone
Any
else?
question? No?
Last question?
Physics, material science, people.
Everything is clear, the ratio of metal and complex in the synthesis. How can it is an trial and error, or you
No,
take
it's
it
not a
from
trial and error.
literature?
It's coming from the coordination chemistry. Okay, whenever we discuss the 2-gem-1 in case of the copper, and in case of the silver, I took the 2-gem-2 because the 2 slit is there and 2 symmetry units is there. So this is coming from the coordination chemistry.
Okay, and if you want to carry out your research work in further, which metal complex you choose and what is the reason behind this?
From the order data, we know that the silver complex and sulfamethosol have the more DNA interaction study, right? So maybe what we do, that is the NS2 group is there, right? And in case of the chlorine, in the silver complex, sulfachlorobiodazine, that minimum inhibition concentration is increases, and that is because of the chlorine is there. So now what we do, we know that the silver SMXs have the higher DNA binding study. So now we add some function group that coming from the ketone, maybe coming from the aldehyde, and check that biological activity is increase in presence of the halogen molecule or not. This is maybe we use another moiety to increase or enhance the effectivity of the drug, or maybe that also reduce the toxicity in case of the AGSMX, because AGSMX have the higher toxicity. So particularly for the toxicity, if you want to reduce the toxicity, then you must be add something that useful to reduce the toxicity. This is a way maybe useful.
Any more? You got your answer?
Yes, ma'am.
She can't say no. Anybody else? So if not, we can congratulate you.
Yes.
So from now on,
So,
here,
you want to ask something? No.
अशोक को तो सबसे पूछा था। अशोक बस उसी से देख लिया, वो खुश हो गया। आज उसको पूछा, so now your Dr. Bhavesh. Yeah, clapping here. Popular person.
This is the most awaited vibe of the Department of Physics.
No, when I was doing my master's, no, in my final year MSc, he taught us the project work. At that time, he was first year PhD student under madam. So we were the project students, and we carried out our work under him. And now I am almost in my final time of my PhD. So it's a long time, so it was most awaited one like that.
So congratulations, Dr. Bhavesh.
Only MSc students are there, right? Can you just say, address to basically the why one should do PhD? Because many of them must have grabbed that. Because there were some 9 chapters. And how many years?
4.5.
4.5. So
So those are
lot of work you have done it. So, and presented it, remembering all the things and all that. So, why you feel that PhD is still interesting?
उसके दो रीजन है सर, दोनों तरफ मैं बोलना चाहूँगा। वन आई विजिट ना मटेरियल साइंस, मैडम वहाँ पे थे, तो मैडम एक गर्ल के साथ बात कर रहे थे कि आपको कल ऐसा बोल रही थी कि सर हमें जब मैरिज करना है तो किसके साथ करना चाहिए और क्यों करना चाहिए, राइट। और मैं उसके नियर में ही था, तो मैडम बोल रही थी कि कोई PhD स्टूडेंट मिले तो अच्छा है। मैंने दूसरा क्वेश्चन वाला पूछा, वो लड़की ने नहीं पूछा पर मैंने पूछा कि वाई, मुझे नहीं पता। तो मैडम बोले कि PhD स्टूडेंट वहां से आते हैं ना कि उसको आप कुछ भी बोलोगे वो एकदम ग्राउंड स्टेप ही रहते हैं, आपको उसको डांटोगे तो उसको बोलोगे कि रात के 3 बजे काम करना है तो भी वो कर सकता है, वो कुछ भी कर सकता है। क्योंकि वो जो मैडम थी ना उसके हस्बैंड PhD करके आए थे, वो बोले थे कि मेरा वो पूरा एक्सपीरियंस है। दिस इज वन साइड। नाउ सेकंड इज वेरी इंपॉर्टेंट, राइट, बिकॉज जब हम PhD करते हैं, राइट, तो हम क्या करते हैं, कुछ नया फाइंड करते हैं, राइट। ऐसा तो नहीं कि हम नोबेल प्राइज लेके आएंगे, लेकिन ना बूंद बूंद से ही तो क्या वो होता है, राइट। तो आपका जो PhD आप कर रहे हो ना तो इट्स यूजफुल फॉर द कंट्री। सो पहला आपका फोकस ये होना चाहिए कि मैं जो काम कर रहा हूँ, राइट, वो थोड़ा सा भी बूस्ट करे अपने इंडियन रिसर्च को, राइट। तो दैट इज माय फर्स्ट गोल, राइट, एंड आई थिंक दिस इज इम्पोर्टेंट। एंड सेकंड, जब आप PhD करते हो तो उसके बाद या फिर आप एजुकेशन में जाओगे या फिर रिसर्च में जाओगे, राइट, तो आप उस लोगों के सराउंड में होते हो जो यंग होते हैं। तो स्टिल रिटायरमेंट आप सराउंड किसके होते हो, यंग पीपल। तो यू आर एनर्जेटिक to the retirement.
You always do. See, I agree to this one.
Yeah, as the madam is never old. You can see the excitement of crystallography and the field of crystallography which she has lived and still exists. The passion she shows still, that's tremendous.
और हाँ, मैं लास्ट में अपना एक्नॉलेजमेंट में लिखा नहीं कि मुझे बोलना था, राइट। मैंने जब मेरी एग्जाम क्लियर हुई, आई एंड अंकित ना साथ में हमने प्रिपरेशन की एग्जाम की, दैट टाइम मैडम इज हेड, राइट। तो जब मेरा सिलेक्शन हुआ तो मैडम ने बोला कि आपको मेरे अंदर करना है क्रिस्टोग्राफी। मुझे क्रिस्टोग्राफी इंटरेस्ट था, तो मुझे लगा कि 2-3 दिन लगेंगे रजिस्टर होने में, तो घर जाके आते ऐसा कुछ। रात को मैडम ने मेरे एक सीनियर थे दुबे भाई, तो उसको फ़ोन किया कि वो लड़का जो है ना उसको बुला। तो रात को मुझे फ़ोन आया दुबे भाई का कि आपको बुला रहे हैं। तो मुझे लगा कि अभी तो रजिस्टर हुआ नहीं, तो अभी तो काम चालू नहीं होगा, राइट। तो मैं गया तो मैडम ने बोला कि आज से काम स्टार्ट करना है, इट्स 10 o'clock एट नाइट, राइट। तो मैंने बोला कि मैडम आज से ही कर दूँ, तो हाँ रिसर्च ऐसे ही होता है, कैसे करेंगे। तो मैडम ने बोला कि अगर आपको बढ़िया क्रिस्टोग्राफर बनना है, किसी को भी बढ़िया क्रिस्टोग्राफर बनना है, तो आपके ना हाथ जो होते हैं ना वो और अपना दिमाग दोनों एकदम क्लीन होने चाहिए। अगर उसमें से एक भी अगर क्लीन नहीं होगा ना तो आप कभी क्रिस्टोग्राफर नहीं बन सकते, राइट। और वो मैंने फॉलो किया कि whenever जब मैं क्रिस्टल ग्रोथ करता था ना तो मेरा ध्यान वहीं भी होता था, और इसलिए मैं भी आई हैव मोर नंबर ऑफ द क्रिस्टल ड्यूरिंग माय PhD.
So when he said these few words, I add something. I think whether what he remembers or not, I don't remember also. But I have seen on my days that he would grow the maximum number of good single crystals. And few of my PhD students' thesis, I have to borrow some crystal from it by fighting and give it to them, because I have an idea that we should minimum 6 crystal or 8 crystal. Like beginning we used to keep 10. Then I decreased because as students का strength कम हो जाता है ना, then we decrease the number of crystals. Then it was 8. Then I stopped at 6. If anyone wanted to do PhD, they have to do at least 6 crystal. But then some students are there, they got 4, 3 bus, madam pati go, oh nahi tha. Oh, we cannot go because crystal won't come. But here given the crystals, borrow or whatever it is, and their thesis was completed. There are, I don't want to name, but that was him. He still maybe having some good number of single crystal.
Anybody wants to do PhD, अभी ये है यहाँ पे.
बहुत अच्छा हाल है इसका. And
So
the way he learned,
growing crystals is an art. So you are a magician.
I would like to some memories with him.
Yeah, that you can carry on.
बड़ा क्रिस्टल है. तो 2019 में हम दोनों बस में रात का काम करते थे. ऑलमोस्ट ऑल नाइट दोनों डिपार्टमेंट में. वो धीरे धीरे पूरा जो स्टेयर है वहाँ यहाँ से स्टार्ट करता वहाँ तक वो बीकर रखता था बाहर, और ईच एंड एवरी बीकर में कंटेंट रखते पूरी रात फिक्स करता था, सुबह अंदर रखता था। ऐसा 2-3 महीने चला। बाद में बोले करेगा क्या इतना बड़ा, ठीक है, जितने भी मैं करूँ या ना करूँ, तो मेरे आगे जनरेशन आएगी उसको भी काम आएगा। डेटा अभी जितना पॉसिबल है इतना एनर्जी हमारे पास सब कर देंगे। तो हमारी मेमोरी है तो हमने ऑलमोस्ट 4 साल सबसे ज्यादा रात में डिपार्टमेंट में रहने वाले हम दोनों ही थे, ड्यूरिंग आवर PhD। सो Bhavesh, almost 10 years.
Big crystallographer.
Okay, thanks to all my PhD scholars, future doctors, and my MSc students.